Okay, so first of all, I would like to tell you basically the reason I don't like it is not because this is hard, it is because it has a lot of chemistry, and chemistry is my least favorite subject. So, suppose in chemistry, right, it's magnesium 24, it's written like that. Okay, basically, this number that you call the nucleon number in chemistry has a lot of meanings. For example, the first thing that it shows is the total number of nucleons. Nucleons are basically protons and neutrons. Okay, then also this number shows mass of 1 mole of magnesium. So if it was oxygen, which is I think 16, so it would be 1 mole of oxygen is 16 grams, like that. Okay, and then this is the most stable isotope amongst all magnesium isotopes. Also, you need to remember that how this number comes is that it is 24 times heavier than hydrogen atom. So you just need to remember that. Okay, who doesn't take chemistry in this class? Can you please tell me? Everybody
Me?
does? Me who? Suha.
Yeah.
Okay, so I'll be then giving you a little bit more detail. So you have not taken chemistry in IGCSEs as well?
The thing is, I was in India before this year, so I had different syllabus. So
Okay.
I had to do it till grade 10, and then I started year 12.
Have you done moles in it?
Yes, but I was terrible at it, so I
Okay.
don't remember
Okay.
anything.
Same. Never mind. We'll do it. Okay. So before then, we have to move towards prereq because Suha hasn't done it. So there are prerequisites to this, okay, that we need to follow along, and I just want everybody to focus here as well, even if you know this. Okay, so the first thing, this is from AS physics as well. You need to understand that this value of unified atomic mass, and this is U in physics. You used to use it in AS, I think nuclear physics. Unified atomic number 1U is basically defined as the standard unit for weighing masses at atomic scale to 1/12 of the mass of a carbon 12 atom. So basically, this number that you learned in AS 1U, which was 1.66 times 10 raised to power minus 27 kilograms, this thing basically means that it is 1/12 of the mass of carbon 12. Is it clear, everybody?
Yes, sir.
The next thing you should know is the Avogadro's constant, and this is given in the exam data page as well. Okay, so it's written with Na. Avogadro's constant means that basically 1 mole, when you say 1 mole, is equivalent to 6.023 times 10 raised to power 23 particles. This is what it means. Okay. Now, the third thing you guys should know is how to find moles. So there are two basic formulas that we're gonna use. Number one is number of moles is given by n, and it is basically n over Na. Okay, so I'm just gonna write what is n. N basically means number of particles, whether it's a gas, it's any other material, and this is Avogadro's constant, right? The other formula to find moles, you got to remember that number of moles n is equivalent to m over mr. Now this has a particular thing in it. This is the mass in grams only. So you have to convert, if it's given in kg, you need to convert it. And this is called, the mr is basically the molar mass. Molar mass is basically the number that we learned, like Mg is 24, oxygen is 16, carbon is 12. Do you guys understand this?
Yes, sir.
Now, we're gonna do it like... yes.
The molar mass is basically the atomic number, right?
It is the atomic number, that's correct. It is the atomic mass, not the number. Is there a difference between them? I don't know. Means
Yes, sir. Atomic number is different.
like 12, carbon 12 and 16, right? So we're talking about this. I think this is atomic mass, right?
Yeah, that's the atomic number.
Yeah, not the atomic number, that's correct. Okay, to find the moles, it's pretty simple, right? I'll give you very basic examples. So those who haven't done chemistry and who haven't done it right also should know that, let's suppose the question says that there are 300 grams of helium compressed in a cylinder. So they say determine the total number of particles in helium, which is given by 4 and 2, like that. Okay, because we have mass and molar mass, so first of all we would like to find the moles, which is m over mr. The mass is 300 divided by 4. 4 comes from here, and then this will be 75 moles. Then to find the number of particles, we can do n equals to n over Na, and here n will be equal to 75 moles times the Avogadro's constant, which is 6.023 times 10 raised to power 23. This is going to give you 4.5 times 10 raised to power 25 particles. Is it clear? It is that easy. Understood?
Yes, sir.
Okay, so these are the basics that you need for this chapter. There's nothing fancy. Now, the interesting thing is that we need to understand the equations of state. Okay, now equation of state, you might have already done it basically, but you don't know you have done it. This is the thing. So in O levels we learned that pressure is inversely proportional to volume of a gas, remember? And pressure is directly proportional to the temperature. Basically, the first one was the Boyle's law, and the second one was the
Sir,
pressure law. Yes.
in the example, what's the last thing you wrote?
Particles. Which in red or black?
In black.
Helium. Helium symbol is He. Okay. He42. Is it clear?
Yes, sir.
Okay, so generally we would write this as pressure is written as P, inversely proportional to V, and pressure is directly proportional to T, like that. If I combine these two, then basically pressure will be proportional to T upon V, just like that. And that's basically it. Now, when you remove the proportionality sign, you got to put a constant here, and this constant is K T upon V. Now, the examiner is gonna ask you exactly the same thing. He's gonna say, what is an equation of state, and name any constants you use, right? So we're gonna explain this in a bit. So when the examiner says, we are going to say that PV over T is equal to a constant where, and then we're going to explain this, right? So this is what in blue, this is what you need to write when he's asked you this. P is the pressure, V is the volume, and T is the temperature. And this is not just the temperature, you just need to remember this temperature is in thermodynamic scale, which means it has to be in kelvins only. Is it clear, everybody? Do not take this temperature as Celsius. Understood?
Yes, sir.
Now, so there will be two equations that we've basically, those who study chemistry now, they will also learn it, and those who learn physics now, they will learn the chemistry equation and the physics equation, but in physics we use both of these. So the chemistry equation basically is that this PV upon T has a constant which is equal to nR, right? Where I just want to tell you that this N is the number of moles and this R is basically molar gas constant, which is also given in the data, and the value for this is 8.31 joules per Kelvin per mole. So you got to remember this. Okay. The physics equation is PV upon T, which is equivalent to capital N and small k. Okay. So this N is basically the number of particles, and K is called the Boltzmann constant. This value is also already given. Okay. The Boltzmann constant is basically, let me just give it to you, 1.38 times 10 raised to power minus 23. Is it clear, everybody? You don't need to remember this. This will also be given. Okay. Now, so both of the equations will be used, and you just need to use the appropriate equation according to the need of the question, which means whatever type of data is given, you can just use one equation to save time, right? Well, I have remembered these equations as PV equals to nRT and PV equals to nKT, because it seems more natural to me, but it's okay if you remember the other form, it doesn't matter. Now, the thing is that there is no such thing as an ideal gas, really. Okay. The ideal gas is based on certain assumptions, and that we need to remember. Why? Because in this chapter there's a lot of rote learning, because what he's going to do is he's going to give you there are actually total 5 assumptions. So he's going to give you 3 assumptions in the question, and then he's going to directly ask what are the 2 other assumptions. So you have to remember every assumption, right? Because he can give you any assumption and then ask the other ones. So before we go on, I just want to write one note here so you don't forget that T is always in kelvins. Never take it in any other unit, please. Okay, now, so we're going to talk about the assumptions that the ideal gas depend on. So the first assumption is that the volume of ideal gas particle, okay, is negligible, okay, seems like right spelling of negligible, compared to the volume of container containing the gas. So it means that the volume of the particle should be very, very small compared to the container, right? The second assumption is they have no intermolecular forces between them. Basically, intermolecular forces are another word for electromagnetic forces. Okay, so basically what we're saying is that they are not attracted to each other or repelled by each other. Okay, now third assumption is that the collision of ideal gas particles are perfectly elastic. Who knows what is meant by perfectly elastic? Anyone?
No energy is lost.
That's not correct. Which kind of energy is not lost?
Kinetic.
Kinetic energy, you're right. The kinetic energy before and after the collision is same. Right, that's correct. Okay, then 4. The fourth assumption is that the time of collision is negligible compared to time interval between collision. Now, this seems confusing, but basically what it means is that when the particles collide, let's suppose if they collide for 0.001 second, the interval between the collision, when they come back and collide again, that should be like maybe 5 seconds, 10 seconds, whatever. Do you understand? So it is larger than the actual collision, the interval. Is it clear, everybody?
Sir, can you repeat that?
It means basically there are two particles, so one is here, one is here. If it goes and collides, so maybe it's 1 second, and when they collide in reality, like when they collide with each other, this collision should be like 0.00001 second. So it should be negligible with compared to the interval at which they collide. Do you understand?
Yes.
Okay, it means like that. Okay, and then the last thing that you need to remember is that at any given time, there are always a large number of particles for statistical approximations to be made. At this point is like you can't just, there has to be thousands and millions of particles here. You can't just rely on one particle. Okay. if somebody wants to know more about this, okay, they can always discuss me. It's out of the syllabus, but you can also Google it about Maxwell distribution. This is just for, extra knowledge if you want to take it. All right. Now, so these 5 points must always be remembered by heart. Okay. So the best way is that you guys should start doing a tasbih. You know what is a tasbih?
Yes.
Take some beats and start learning. Okay, like that. It's so important. Why? Because
Interesting way.
yeah, yeah. I'm actually not kidding, because if I show you exactly how important this is, let me just open the papers. Wait, here it is. Where is this? Ideal guess 71. Let's go down. Okay, so you will basically see every single place they're gonna ask you this. Wait, come back. Like, you see, one assumption of kinetic theory of gases is that gas molecules behave as their hard, elastic, identical spheres. State two other assumptions. So if you don't know, you can't write them, right? And then similar questions everywhere. Similar question. Now, the kinetic theory of gases is based on some simplifying assumptions. The molecules of the gas are assumed to behave as hard, identical spheres. State the assumption about ideal gas based on the nature of movement and their volume. So basically now he has restricted you to the first point, which was the volume 1. Also, the nature of movement, right? The nature of movement basically was
The fourth point?
yeah, exactly. Do you understand? So you have to make sure that you remember all this. Again, by reference to one of the assumption to kinetic model gases, your answer deduce what is meant by internal energy. So basically this is the collision one, that they're perfectly elastic. So the thing is, and state what is meant by gas, obeys PV is equal to T, PVT, and I wrote explained for the other kids, but you need to basically write pressure, volume, and so every single question you will open, like every out of 5 questions, 3 questions will ask you this. So you should always remember this, okay? That's this important. Anyway.
Sir, how is Maxwell distribution related to the last point?
Maxwell distribution curve basically tells it's a statistical evaluation, right? So at the end of the class, let's discuss it, but that's not part of the course. It is a curve that's based on how ideal gases behave. So you have to check it. He has done it, basically, the scientist behind it. It's Maxwell. Okay. Now, so going to the next part, and now let's do a question. Okay. So.
One second, can I just know the last?
Sorry. Come again, Rafa?
I just have to know the last point.
Okay. You can write it while I write the question. So helium gas in 1 into 10 raised to minus 3 container has a pressure of 1 atmosphere, which is 1.01 times 10 raised to 5 pascals, and a temperature of 26.85 degrees Celsius. So it says calculate number 1, number of total atoms present at this temperature. And then let's write part 2 as well. The volume that contains 1 mole of helium 4H2. Okay. So we're going to discuss 3 types of basic questions, which will again be repeated every single time. So which makes this chapter also very easy. So first of all, it says number of total atoms present at this. So there's certain things that you need. Of course, you need to know about, I think, R. R is 8.31, and K, Boltzmann constant, is 1.38 times 10 raised to minus 23. Okay, so you can check it from the... Yes.
Do we change temperature to Kelvin?
Exactly, this is my point, okay? So they say exact value of temperature, by the way. The equation, right? Temperature in kelvins. Sometimes you got to use it when he asks you this, otherwise you can take 273. But sometimes you just need to take the exact value, which is 273.15. Okay, so that's the extended value. Sometimes he will give you this, so you keep 0.15. Sometimes it's not needed. It depends on the question, really. In this question, it's needed. Anyway, so first of all, I should know. Currently, I have volume, I have the pressure, I have K, and I have the temperature. Which equation of state should I use? What do you guys say?
PV by T equals to K.
Yeah, NK. Yeah. PV equals to NKT would be the ideal equation. So it depends on what kind of question this. So now the pressure is 1.01 times 10 raised to power 5. Volume is 1 into 10 raised to minus 3. N is what we need. This is 1.38 times 10 raised to minus 23. And the temperature, we got to convert this. So we convert it by adding 26.85 plus 273.15. So it is in kelvins. Okay. Which makes it basically 300. So N, you should expect it to be 2.4 times 10 raised to 22 particles. Is it clear, everybody?
Yes. Also use PV equal to nRT, right?
We can use it. Then you have to find moles first. Then from moles, you have to find Kn. So that would make 2 equations. Why would you do 2 equations? Okay. Wait a second, please. Hello. Hello. Okay. All right. So now in the next part, it says the volume that contains 1 mole of helium. So now because we have mole, so what you can do is we can find the equation. The best equation would be PV equals to nRT now. Okay. So PV equals to nRT. So we have the same pressure. So let's write the pressure 1.01 times 10 raised to power 5 times volume. The mole we need to basically do in 1 mole, right? So that's 1. R is 8.31 and the temperature is 300. So that makes it 0.025 meter cube. Is it clear, everybody? So, like I said, you just need to decide which equation to use. Depends on the whole thing. Now, let's go to the next question. Okay, wait. Alright, so in about 1 minute and 45 seconds, the meeting will close, so you have to rejoin the same link, okay? While I'm writing the question.
You doing the same link?
Yes, my link is the same every single time. So it says a container has a volume of 500 centimeter cube and its initial pressure is 98% of 1 atm, which is basically 1.01 times 10 raised to 5 pascals. Which initial temperature of 26.85 degrees Celsius. The gas is then expanded by 200 centimeter cube, so that All right. Okay, so I was writing that so that the pressure,
So it's 26.85, right?
yeah,
Or
yeah,
is 05?
85,
Okay.
85. Okay, where was I? Where was I? Where was I? Okay, so the pressure decreases by 0.33 atmospheres. Now it says calculate the final temperature in Celsius. Okay, now, so remember when only the conditions are changing such that it's like the pressure changes or the volume changes, something like that. So you need to use the ratio. So you need to understand that pressure and volume over temperature is equal to a constant, which means that when comparing the same gas, we can write P1 V1 over T1 and P2 V2 over T2. In O levels, you had done P1 V1 equals to P2 V2, but now you also need to include temperature. That's the whole thing. Now you don't really need to do anything. 0.98 of ATM would be 0.98, right, atmosphere, times the volume at that point was 500. You don't even need to change anything, but this is a ratio, right? But you need to change the whole thing, right? You can actually use directly, I think you can use directly the Celsius one too, because it will give you the same thing. It doesn't really matter, I think. Well, I need to check it. And then it says it decreases by 0.3. So before it was 0.98. So when it decreases by this, so we have to subtract this, right? This would be ATM. And now the volume increases by 200, which means 500 was original volume and now increases by 200 divided by the temperature T2. If you do this, the temperature is going to be 5.42 degrees Celsius. Is it clear, everybody?
Yes, sir.
Okay. Now,
Sir,
yes.
delta T will be 5.42, right? Not T2.
It will be T2, I think.
Oh, okay.
Yeah, it won't be that. Because we're not finding any change, okay? Is it clear? Okay. Now, you can, even if you convert it to kelvins and then you have to reconvert to Celsius later. It's up to you, really. Okay. Now, the last type of question that they're going to give you is the helium gas at a temperature of 16 kelvins and a volume of 0.25 times 10 raised to power minus 3 meter cube is contained in a vessel at a pressure.
So when I tried solving that question, I'm getting 24.9 degrees Celsius.
You're getting 24.9? Then
Yes,
probably,
yeah.
let me check, because there has to be some calculation error with me as well. Because maybe we need to convert it. Wait a second, please. It might not give you the right answer. Can you check if I write it 300 kelvins, what do I get as T2? I think it should give you like 278.57 Kelvin.
Yes, sir.
है ना? And then you subtract it from 273.15. What do you get in Celsius?
5.4.
Yeah. So you need to convert it actually. All right. Now, so helium gas at a temperature of 16 Kelvin and the volume of this is contained in a vessel at a pressure of 2.5 times 10 raised to power minus 5. 2.5 10 raised to 5 pascals. Okay. Now, so first of all, it says determine the number of moles of helium. Then in the next section says here determine the mass of helium in grams. Okay. Now for this one, the first thing you guys need to know is because we have to find the number of moles, which equation should I use? Who can tell me this? PV is equal to
Energy.
nRT. Very good. Now you guys understand. Okay, so the pressure was 2.5 times 10 raised to 5. The volume was 0.25 times 10 raised to power minus 3. N is what we need. This is 8.31 and this is 16 because it's already in kelvins. The moles, you should expect them as 0.475. It might be a little bit different in the answer, but that's how it should be. Can you please check it once, because maybe I made wrong calculation. Wait, here you go. 2.5 times 10 raised to power 5 and then times 0.25 times 10 raised to power minus 3 divided by 8.31 divided by 6. Divided by 16. Yeah, it's 4.70. Not that. Okay. Now, the next thing you're gonna do is you need to find the mass of helium in grams. Can we do it from some equation? You guys know?
N equal to M upon M.
Yeah. So we're going to use the mole equation, which is M over mR. So N is, we do have N, 0.470. And M, this will always be in grams. Helium is 4, by the way. So we're going to multiply this 4 times, because my previous calculation is wrong, so I have to do it again. 0.47 times 4. 1.88, which is basically 1.88 grams. Is it clear, everybody? So
Yes.
so it's basically these sort of questions. There are 3 types, so let me remind you. First type is when they are going to ask you to find volumes or temperature. Second is the ratio question, and the third is when they ask you to find moles and mass. Except for this, there's no other type of question. Yes, the question wording might be changed, there might be some diagrams, but overall this is the crux of the whole chapter. Okay, if you have any questions, please let me know now. Okay,
Sir, can you show the second question?
second one. Yes.
So why did you subtract 278 from 273 and not 300 at the end?
Because if you look at the equation itself, right, the equation, we had the temperature in Kelvin. So temperature in Kelvin is given by temperature in Celsius plus 273.15. Okay, so if we have 278.57 as the answer, then we got to subtract 273.15 to find temperature in Celsius. That's why.
Okay, I thought we are subtracting from the initial temperature. Sorry.
No, we are using the equation. It has a constant factor in it. Okay? Is it clear?
Yes.
Okay, so that would be, I think, all for today. Yes,
So,
yes.
this might be a silly question, but where do we get the value of 300K from?
Oh yeah, how did we get the value from 3? Because basically, we have the initial temperature is this, right?
Yeah.
So what you do is that you add into the same equation. So we want to find Kelvin now. So Kelvin equals to temperature in Celsius is 26.85 plus 273.15 is equivalent to 300 kelvins.
Oh, right. Yeah.
This is the main equation is this one. This is what we're using every single time. All right.
I got it.
Yeah.
That's why I said my silly question.
No, it's fine. It's a good question. Everybody might be confused, because certain things I assume in my head that you remember from O levels, which is my bad. Okay, so this is the equation. I think I wrote this equation somewhere before as well. Here, I wrote this equation.
did.
I think. Yeah. Okay. All right. So that would be it, and I hope to see you next class tomorrow. Bye. Have fun.